Hey guys, welcome to Selective Prep Mathematics. Pardon me. Test number 6. This is the solutions video for the exam. So I believe I said last week would be the last time I said this, but I've decided to say it for a little while longer. So it's important to make sure that you watch all these videos, because otherwise setting the exam becomes a little bit pointless if you don't know what you've done right and what you've done wrong. Okay, so that's what the solutions videos are for, but we also have a little bit of an overview. Okay, so just before we get started with the solutions, we're going to take a look at a couple of topics that I found might have been a little bit difficult, or I thought I could explain a little bit better to help you save some time. So the first one's going to be converting percentages to decimals to fractions. Okay, so basically it's basically a matter of multiplying one or another by 100. So a decimal is a percentage divided by 100%. Okay, so you're going to get rid of the percent as well, obviously. So 0.9 is equal to 90%, okay, but it's divided by 100. Okay, so it's 90 over 100, so it's 0.9. Now, if I were to say, what's 90% of 100? Okay, it would be the same as doing 100 times 0.9. It would equal 90. Okay, now a fraction equals a decimal in whole number form. Okay, so it's that exact number, so it's the decimal, it's the decimal, or it's the percentage on its way to decimal. So when we try and make a percentage a decimal, we divide it by 100, right? But instead of actually completely dividing the number by 100 to make it a decimal, we leave it as this. And in that, or as one number divided by another number, okay? And then in that sense, it becomes a fraction. Okay, so 75 divided by 100 is 75 over 100. Now we can simplify that, divide it through by 25, gives us 3 over 4. Okay, so when we're trying to convert from decimals to percentages, we divide by 100. From percentages to decimals, we times by 100. Okay, other way around. So percentages to decimals, divide by 100. Decimals to percentages, times by 100. And when we try and get fractions, okay, it should be that in-between point. All right, so when we are trying to convert from fractions to percentages, fractions to decimals, okay, we use percentages or decimals to get from one to the other. Okay, so for example, converting a fraction to a percentage, convert it to a decimal first. So 3 over 4 is the same as 0.75. Okay, if it's the same as 0.75, okay, that's the same as 75%, or vice versa. Now, fractions. So using a common making a common denominator when we're using fractions, also called the lowest common multiple. So when we're using a common denominator, it should be the lowest common multiple. So when we do look at a question, the first thing shouldn't be to just multiply. This is usually when we have like 5 different fractions together. Sometimes there's 2 different fractions together. You can just multiply them together and all the denominators together, and that gives you the LCM. But otherwise, do not just multiply all of them together at the start, because otherwise it's not gonna give you the LCM. Now, when we are looking at this example here, okay, so we have 4 over 12, 8 over 16, 1 over 24. The most important rule is to simplify every fraction first. Simplify first, because this is going to give us smaller numbers that are going to be easier to work with. So 4 on 12 is 1 over 3, half, and then 1 over 24 for the following numbers. The lowest common multiple out of 3, 2, and 24 is 24. Okay, so again, this is why I said don't multiply them all together, because you could have the LCM there already, and you just need to change 2 of the fractions, not all 3. So what we're going to do now is try and make every denominator into 24. So obviously 1 over 24 stays the same, but half, you multiply top and bottom by 12, 1 over 3, you multiply top and bottom by 8. Okay, and then those will give you denominators over 24, and then the correct numerators as well. Add them together, you should get 21 over 24. Now, last thing we're going to look at is multiplying by a fraction. So we always want to use the simplest steps, like we said in that previous slide. So what you want to do is you want to divide before you multiply, because otherwise, if you multiply first, you're going to get a very large number, like so. Okay, so example 43 over 96 times 192. If you divide this by, if you divide 192 by 96 first, you get 2. Okay, you get 2, and then you can multiply by 43, all in your head. Okay, it's always faster to do things in your head than to write it out. If you want to do 192 times 43 and then divide it by 96, okay, that's going to take you a lot of time, and you're also going to have to write it. Now, if you had listened to my first step, sorry, actually, I take that back. Don't worry. Now, let's get straight into the questions. So 5 identical rectangles formed to make the rectangle or the shape below. Okay, so mind you, this whole thing is 15, not just this one side. So this one side, if this shorter side is 6, then this is going to be 6, and then this is going to be 9. So our rectangles are going to be 9 times 6, and there's 5 of them. So it's going to be 9 times 6 times 5. So it's going to be 6 times 5, 30, 9 times 30, 270. Alright, 2 types of candy are sold at the milk bar. One is more popular than the other. So candy A sells 3 packets to every 2 packets of candy B. So it sells at 3 over 2 times the rate. So how many packets of B were sold if the milk bar sold 42 packets of candy A? So if A sells 3 on 2 times of B, well then it's B sells 2 on 3 times of A. Okay, you just flip it around. So A equals 3 on 2 B. Now, when you move it over, okay, top and bottom just switch, right? Because this is a divide and this is a times. So times becomes divide, divides becomes times, and you just flip them over. So B equals 2 on 3A, 42 times 2 on 3. So divided by 3 is 14, times by 2 is 28. Now, Albert bought a 50-inch plasma TV for $5,400. It pays a deposit of $800, so he has $4,600 left to pay over, and then makes monthly repayments of $200, which should take him 23 months to pay it off. Mr. Sting paid $153 for a pair of shoes at a 15% sale. So 15% means he only paid 85% for it, so 180 times 0.85. So we've converted our fraction, or we've converted our percentage to a decimal. Okay, so technically this should say decimals here. So 180 times 0.85, or that's the same as 180 times 85 divided by 100. Okay. Oh, sorry. No, that's not what I should be doing. I've just used the answer. So 153, okay, x times 85 over 100 equals 153. Okay. I've got to do this as if I don't know the answer. So if I move the 100 over, okay, it's 15300 because it becomes a times, because if it's on the bottom, it's a divide. So when you move it over from the bottom, it becomes a times. And then what was on the top now becomes a divide. So we're dividing through by 85. So that goes in once. Okay, what's left over? So you should be left over with 68, I believe. 68 goes into 85 8 times. And that's it. Okay, and then it goes into 0 times. So 180 is what you get. Question 5, I think of a number, I square that number, sorry, that should say, so I think of a number, square it, multiply it by 2. I subtract 5 from the result, add 10, and the result is 23. So overall, this is minus 5. If I multiply the beginning number by 5, the result is what? So if I move this over, 2x squared equals, equals 28. I don't think I'm doing this right. So I think I've missed a step. So I square that number, multiply it by 2. I subtract 5 from the result. Yep, add 10. And the result is 23. Sorry, so this should be plus 5. So when I move it over, it becomes a minus 5. So this should be 18. So x squared equals 9, x equals 3. Now, if I multiply the beginning number by 5, okay, well, that's going to be 15. Okay, so lesson of that, the moral of that question was read the question properly. Okay, take your time when you're reading it. Make sure you don't make any silly mistakes. Because even if I try and read it quickly, and I know the answer, then I'm going to screw up as well. So make sure you guys read it carefully too. So question 6. So this is a composite shape. Let's break it down. So if this whole area is 6 and then this is 2, okay, this area here is going to be 4. That's all I need to know. So this is 4 times 8 here. this is 24 times 4, and this here is 2 times 3. So it's going to be 6, and then 4 times 8 is 48. 24 times 4 is 96. So that's, these two together are 102 plus 48 should give me not 100. Okay, I think I've done something wrong. So 696, 4 times 8 is 32. Okay, so 102 plus 32 is 134. Again, don't try and rush things because it's going to make you make a silly mistake. 7. Sophia discovered she could subtract 6 from age. So let's say her age is x. Subtract 6 multiplied by 7. It's the same as subtracting 7 and multiplying by 8. Okay, so let's expand these out first. And then 8x minus 56. So move this, no, let's do it the other way around. So move this over, so you get 56 minus 42 equals 8x minus 7x. So 14 equals x. Question 8. There are 10 marbles in a bag. 5 are green, 3 are red, 2 are yellow. What's the probability of picking 2 green marbles, one after the other? So we're assuming that we're not putting the green marble back after we pick it out the first time. So the first time, the chance is 1 over 2. Multiplied by the second chance, okay, where it's going to be, so 4 over 9 now, because there's 1 less green marble, and then there's 1 less marble in total, so 4 over 9. So multiply top and bottom, so 4 over 18 equals 2 over 9. Question 9. How many 3 on 4 meter lengths of timber can be cut from a 6 on 1/3 meter timber? So this one's a little bit difficult. There's 2 ways you could have gone about doing it. I'll just try and make this one. I'll do the way I did it was make this first. This first. I can't remember what it's called actually. Sorry, I've just had a mind blank. Let's just call it a composite fraction. I can't remember what it's called, where you have a whole number and a fraction together. I've just had a mind blank, but hopefully you guys remember the name. So it's 6 and 1 on 3. Now, if I make that into one whole fraction, that's going to be 19 on 3. Now, if I divide that by 3 on 4 to see how many times it can go through, okay, it's flip it around and it becomes a times. Okay, so 19 times 4 and then 3 on 3. So 19 times 4 is 76 over 9. So if we divide 76 by 9, we should be able to see how many times it goes into, or how many times 3/4 goes into 6 and 1/3. Okay, so 9 times what goes into 76. So the largest number we can do is 9 times 8, which is 72. Remainder 4.6. Something. Okay, that's going to give us a repeater. The only number that starts with 8 here is B. Okay, so that should be it. The other way I had doing it was just add all the 3/4 together until you get a number that's as big as you can get, till it's not bigger than 6 and 1 over 3. Okay, but just before it. Okay, because it's not going to fit in an exact number of times. But that would have given you 8 and something as well. So the only number you know that's bigger than 8 here is B, so you would have gone with B. Question 10, what is the height of this triangle? So the slanted height is 14. Okay, this little bit here is 7. So what you're going to have to do is use Pythagoras theorem. So Pythagoras theorem is that a squared plus b squared equals c squared, where c is the longest side. So we would have gotten, so 7 squared plus x squared equals 14 squared. Now, 14 squared, 7 squared is 49. 14 times 14 is 196 apparently. So 196, move this over to find x squared. So x squared equals 196 minus 49 equals 100 and what? 196, 156, 147. Okay, can we root that? No, we can't. We won't get a whole number. So it can't be any of these whole number answers. So it's going to be E, none of the above. So the key takeaways from this test was converting fractions to percentages using decimals in between, because that's probably the easiest thing we can use as an intermediate point. So intermediate point just means that little point in the middle to get from one stage to another. Also, when we're adding fractions with different denominators, make them the same. But when we make them the same, we want them to be as small as possible, and this smallest denominator possible that's common amongst all the denominators is called lowest common multiple. And finally, when we're multiplying by fractions, okay, always divide by the denominator first if you can, and then multiply by the numerator, because that's going to save you time. All right. Apologies about all the mistakes I made throughout the video, but that brings us to the end of the video. Good job, guys. I will see you in the next video.